we'd really like Mario to be able to switch pictures now, right? How are we going to do that? So right now I'm always drawing Mario 0. What should I do? How about something like, maybe we'll add a int, what should I call this variable? State or a frame? Let's call it frame. Now how am I going to cycle through the frames? How about frame plus plus? And if frame is more than 5 or 4, and frame is equal to 0, what's that going to do? It's going to say, goes to frame 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So Mario will cycle through his pictures. Now we probably don't really want to always increment the frame. We probably want to increment it only if he's running, right? And wouldn't it be even cooler if the faster he ran, the faster we cycled through the frames? Because that would be more consistent, right? So how are we going to do that? Maybe we'll have another double here that indicates, not there. How about double dist? It's the distance he's run. And we'll say dist plus equals speed, where speed is how fast he's running horizontally. And then we'll say int frame is equal to dist modulo 4, something like that. Do you know what modulo does? Basically says divide by 4 and take the remainder. So that'll give me a number 0, 1, 2, or 3. Wait a minute, I want modulo 5, don't I? Okay, and that way it'll show me the frame, but I can increment the distance he travels by any amount I want, and yet frame will always be an integer, 0, 1, 2, or 3. And the faster he runs, the faster he'll cycle through them. But for now, let's just show you the quick hack because I did that. And I don't have a speed yet because I haven't even dealt with that. But now Mario should be moving. And he's not. That's because I totally forgot to use the variable that I did something with. Yeah, Mario.frame, right? Oh. Model.Mario.frame. I should have compiled and saw the error and showed you how to fix it, but by now you know how to deal with that, right? Okay. So I'm going to run it, and yay, he's totally running. And if I can place the tube in just the right spot, it'll look legit. Almost. Okay. But you get animation, you get gravity, you get simulated Mario, and how close are we getting to a video game, right? We're getting there. I think that's cool. Now, what do we got to do next? Collision detection. Let's talk about that. Yes?
Can you explain again real quickly how the gravity is working?
Yes. And let me emphasize something here, because a lot of times, see, I'm in my model. A lot of times when I ask students to make an animation, like I say, make your Mario able to jump, what they do is they come inside of here and they add a void jump function. And inside of here, they add a loop for int I equals 0, I is less than 100, I plus plus, because they think they're going to need 100 frames of jumpingness. And then inside of here, they come up with some equation for the path he's going to follow, and they try to draw all of the frames inside of here, and you can't really do that because it's the view's job to draw and the model's job to update, and they're thinking about it wrong. And I'm getting to answer this question. I'm saying the thing is you don't need to think about what jumping means over time. Jumping is not a process of 100 frames. We're not doing a sequenced animation here. When I say jump, I'm saying let's just change your velocity and then let physics take its course. Because isn't that kind of what jumping is to you? I am not jumping all the way till the end. I'm only jumping at the very start right here. And then the up and the whole down process, it just kind of happens. So in my update method, I don't need to go through a jump sequence. What I'm really doing is I'm just increasing my vertical velocity and then changing my vertical position by the vertical velocity. What I'm kind of saying is right here, these two lines are the world's simplest physics simulator. And that's really all it is velocity increases at a constant rate. This line right here is gravity. I'm saying, hey, whatever your velocity is, now it's bigger, now it's bigger, now it's bigger, now it's bigger. And why does it keep getting called over and over and over and over? Because that's what update does, right? Update is called by model.update, which is called by, let's go all the way back to our game. Remember, this run function's in an infinite loop, and it's just going to call model update over and over and over and over, 30 frames a second, or 60 frames, whatever your frame rate is. It's just going to keep updating it. So you don't need to do a whole loop. You just need to do what happens at this one moment in time. And at this one moment in time, your velocity gets a little bit more downish, a little bit faster. Does that kind of make sense? So if your velocity is increasing every time we update, your velocity is going to go faster and faster and faster and faster and faster until you're shooting down towards the center of the Earth, unless something else intervenes. So this line right here is gravity. It's gravity because it increases your velocity, your vertical velocity, and that's what gravity does, especially if you consider positive to be in the downward direction, which we do because computer graphics. If we were doing it in the mathematical plane, where positive y means up, then we would have to say vertical velocity minus equals so that it'll go down. But because positive y is down, we need to do plus equals so that you're getting faster and faster in your downward velocity. Now, y is actually your position, right? And position changes by velocity because that's what velocity is. It's change in position. So I'm just saying here, your position increases by however fast you're going. And therefore, that's why these two lines implement gravity. And as long as my view always draws at x and y, see y is the only thing I'm changing, Mario will fall because that's where I draw him, at x and y. So that's how I implemented it, and that's why it works. Do you feel I've answered your question?
Yeah.
Great. Okay. Now, so here's Mario running along. How are we going to make Mario move to the right? We could increase the x position, although he's going to very quickly hit the end of the screen, right? So instead of increasing the x, we're going to do what actually happens in the Mario game, which is Mario doesn't really move. What really happens is the tubes move to the left, and then you feel in your heart that Mario is moving to the right because the tubes are all moving to the left. Does that make sense? So we're not actually going to ever make the x position of Mario change. It's going to be sitting here at 200 for all of eternity. And yet, because the background is scrolling right past him, and by the way, doesn't have to be 200. I just picked a random number. You set it to whatever makes you feel good. If the tubes are moving along and Mario's going through this whole animated running sequence, it's really going to feel a lot like he's running. And then he can jump whenever he gets over a tube. So the next thing we really need to know is how do we stop when we bump into a tube, and how do we not fall down through a tube? And I've already added a simulated perpetual ground right here. Where? There. Okay, what if we want Mario to not bounce off the ground, but just stop on the ground? Well, let's, instead of setting his velocity to -38, God, I can't type today. Let's just set his velocity to 0. 0 means stopped, right? Now, notice that this code comes after this code. So gravity gets its chance to increase the velocity and add to my position. And then I'm just going to say, but actually I'm on the ground, so my velocity is 0. What's the velocity going to be when this function returns? 0, because whatever comes second wins, right? So there's a reason I put this here instead of, say, up here. If you put it up there, then gravity will get its say after you've already brought him to a stop, and he'll actually be below ground a little bit. The other thing I'm going to do is, hey, even though I've stopped him, he might have actually fallen a little bit through the ground, right? because I'm moving more than 1 pixel at a time. I'm moving, you know, maybe 10 or 20 pixels at a time, depending on how fast my velocity is. So I'm not only going to stop him, I'm also going to say y is equal to 400. That way, as soon as he hits the ground, even if Mario falls through the ground, he's going to bounce back up to exactly on the ground. And the user will never know he fell through the ground. Why? Because it only happened from right here, this is when he fell down through the ground, to right here when I fixed it. And I didn't get to draw Mario between here and there, right? He doesn't get to draw until view.update happens. And view.update doesn't happen until after model.update is done. So if for the brief moment in time Mario was technically stuck through the bottom of the ground, but the user never finds out, as far as the user can tell, Mario just falls and hits the ground and lands perfectly on it and never falls through. Right? So let's see what that looks like. Not that it will be that impressive. And we go, and I'm too slow. I couldn't bring it over in time. Basically, he fell and hit the ground, and he's totally running, except that tube should be moving. Come on, tubes, move. Except I didn't implement that, so oh well. If the tubes were moving, it would look cool. Collision detection. This is going to seem a little bit insulting, and that's because it is insulting, and sorry. Does this green box intersect that black box? No. How about now? How about now? How about now? How about now? Yes, okay. Now let's ask why. This box has an X position. Oops. X position and a Y position. The X is how far it is from the left side, and the Y is how far it is from the top. And are we talking about the view or the model? It's up to you. I would do it in model space, because I like to think I'm asking the question, are these things really intersecting? Not, do these things look like they're intersecting, right? And the model is reality, and the view is how you perceive reality. You get that analogy? Okay. Well, then there's also a width, and there's also a height, where the width is how wide this picture is, and the height is how tall this picture is, and xy is this exact point right here. Okay? Well, this box also has a point right here, which I will call x and y, and it also has a width, and it also has a height. Okay. Now, does the green box intersect the black box? The answer is no, but the real question is why? How do you know? Prove it to me. Because x plus width refers to this edge of the box, right? Is less than that edge of the black one. So if green.x plus green.width is less than black.x, then they're not intersecting. If green.x is greater than black.x plus black.width, then they are not intersecting, right? Now, if that one is false and that one is false, they must be intersecting, right? If we were only checked horizontal, but we also got to check vertical. Are these intersecting? No. If green.y is greater than meaning more downish, than black.y plus black.height, then they're not intersecting. And if green.x plus green.height is less than black.y, that didn't come out. If green.y plus green.height is less than black.y, then they're not intersecting. Finally, if none of those are true, they must be intersecting. Did you follow that? Let's do it in code. You could easily write your own collision detection function like this. You don't need a number 4 right there. you could say static Boolean does intersect. And then you could pass in what? Thing green G and black B. By the way, they don't have to be green and black. That's just my example. But then you can say if G dot X plus G dot width is more than B dot X, return false. If G dot X is less than B dot X plus B dot, wait a minute, X plus width is less than, if green dot X is more than black X plus black width, return false. Can you see in this code the same thing I was doing graphically before you just moments ago? If green dot Y is more than black dot Y plus black dot height, return false. If green dot Y plus green dot height is less than black dot Y, return false. Finally, yes, they are definitely intersecting. If all four of those cases fail, you're not to the left, you're not to the right, you're not above, you're not beneath, you must be inside of it. Do you get this code? You should, because I just explained it, and you should be able to use it. Why did I make it static? Because now I can call it from anywhere. I can pass any green and black thing there. You could write does intersect code. There happens to be a rectangle class in Java, and if you make a rectangle containing the x, y, width, and heights of your objects, you can call the does intersect method of it or something like that, and it'll tell you if they intersect. It basically looks like that. I'd rather you implement it yourself. Why? Because then you'll learn something. But if you really just don't want to strain your brain, Java already wrote it for you, as they have done many other things. You can go use their APIs. The one disadvantage of that is it'll be slightly slower because you have to allocate 2 rectangle objects. This code, very instantaneous. Math is a lot faster than allocations. So if you're a hardcore gamer who wants your code to be efficient, write it yourself. It's better that way. And modularize it, right? Stick this function somewhere and just always call the same function. You don't need 5 different do intersect type methods. Yes? Oh, I forgot to say true right there. Yep, you do have to say true. You can't just say return. That would be a compile error. Okay, so there, now we've done an intersection.